Okay, we're going to go through this sheet now and try and remember what the words are for the circle theorems that they represent. And there's a couple of other bits and pieces that we'll look at as well. So first of all, we'll notice that on this diagram, we've got a tangent here and a tangent here. And you'll notice that we've got a radius here and a radius here. Oh, no, we haven't. I beg your pardon. That's not true at all. Those are not radii at all. You should never assume that things are a radius unless they were told that they go through a center. Okay, and that clearly doesn't, because there's no clear indication that there is a center. But we do have two tangents, and we know that the distance between a single point and where the tangent touches the circle are equal. So two tangents from a single point have equal lengths. Okay, also notice that when we join those two tangents together and we split this line, this chord that's created in half, this angle is split in half and it creates a right angle here. Okay, we need to remember that as well. Okay, let's do the second one. Well, let's see. We've got a chord. Notice this isn't a diameter. You should never assume that this is a diameter. Even though it looks like it goes through the center, never ever assume in circle theorem questions that it is a diameter unless you can prove that it is, or you're told that it is. And you're usually told by given sort of an indication of an O or the center in it, like that. Okay, and usually there'll be some text that tells you that it's the center. Okay, so it's not. What we do have, therefore, is a chord that meets a tangent. And remember, if you have a chord that meets a tangent, you should know and think about the alternate segment theorem. So this is the alternate segment theorem. Now remember, that says that if a chord meets a tangent, then the chord subtends an angle. There it is. That subtends that angle here. Then that's equal to the angle in the opposite segment. If it's this chord that is meeting the tangent, then this chord creates this angle, and that angle is equal to the angle in the opposite. So this chord is creating two segments, this one here and this bigger one here, and this angle that's subtended from the chord is equal to the angle in the alternate segment, which is this one. Okay, here we've got a diameter, and that is subtending, and this angle subtends an angle which is at right angles. So a diameter subtends a right angle to the circumference. Okay, the next one. So now we've got a shape. We've got a four-sided shape. It's a quadrilateral, and all four corners are touching the circumference, and therefore this is a cyclic quadrilateral. And what do we know about cyclic quadrilateral? The opposite angles in a cyclic quadrilateral add to 180 degrees. Okay, so we know that opposite angles in a cyclic quadrilateral add to 180 degrees. Okay, next one. Right. One thing I want you to remember whenever you're doing circle theorem questions, this is very important, that quite often there are lines that are missing, and the lines are usually chords or radii or diameters. And in this case, there is a missing chord here. If I put that chord in there, I'll notice that that chord subtends an angle here and here. And I know that a chord subtends two equal angles into the same segment. The chord subtends two equal angles in the same segment. as long as those angles are on the circumference, of course. Okay, this one here, again, there is a missing chord, so notice that's my chord there. And I know a chord subtends an angle to the center, so that's this one, is twice that subtended to the circumference. So the chord, or a chord, subtends an angles to the center twice that to the circumference. And they also must be in the same segment, so this angle is in the same segment as this angle here, and the segment is created. This is the minor segment and this is the major segment, so it must be also in the same segment.